I've had a number of questions about binomial distributions recently and the calculator functions regarding them. So I wanted to give you a little tutorial on how to use these and what these things all mean. Now, we talked about binomial distributions in class. You're looking at success and failure with a set number of trials, set number of successes, and you're given the probability of success. Now, it's all based on combinations. Now, this is the formula for combinations. Like as an example here, I give 10 trials and 4 successes. Those 4 successes can come in any order, really. I could have my first 4 trials be a success, the last 6 be a failure. I could have the first 2 be a success, next 2 be a failure, next 2 be a success, the rest be failures. You get the impression that there are going to be a lot of different combinations here. Now, you can use this formula using factorials, number of trials, successes, plug in these numbers. However, we have a calculator function on here that does that for us, and that is the NCR function. The NCR function, using this, tells us the number of combinations, so we don't have to use this formula. And that's why we like to use this. Now, different TIs, the older ones, you have to enter in a bit differently. Like I have to enter in the number of trials first, then go to NCR, then the number of successes. Some people, you just hit NCR and you just plug in the numbers, 10 trials, 4 successes, probability of success, and then it does it all for you. So part of that just has to do with what kind of calculator you own. But NCR, that's essentially what it means. It calculates the number of combinations for you. And that's ultimately what happens right here. And then you deal with your successes, probability of success, number of successes, probability of failure, number of failures, and that gives us the probability of this happening. Like in this case, we're looking at 10 trials with 4 successes. I said the probability of success was 30%. So I entered in my combination function right here, NCR 10, 4, and notice that's not a fraction. Don't make it a fraction. 30% chance of success, 4 successes, 70% chance of failure, 6 failures. Calculate the probability. So the probability of seeing any combination of 4 successes is going to be about 66.7%. We're all pretty good with that. Now, once we start dealing with the whole Binomcdf thing and cumulative calculations, that's where people start to get a little tripped up. So I want to walk you through. All right, so we're going to deal with white marbles here. I'm going to start you out with number 7 here because this will be a nice introduction. It says the probability of getting a white marble is 50%. Okay. So what I'm going to do first is it says you choose 7 or 8. So in order to find 7 or 8, I'm going to go with the formula. I'm not going to necessarily calculate. I think the formula is the most important part here. So then we get 7 successes, and did I say 10 marbles? Oh, 15 marbles. Okay, I'm glad I checked that. Okay, and then we would have 8 failures. So that's how I'd calculate the combinations for 7. Probability of getting 7 marbles in any combination. Then I'm going to add the probability of getting 8 marbles in any combination. So 8 successes plus 7 failures. And, you could plug the numbers in. I think the most important part right now to deal with is the formula. Now, here's where people get tripped up when we start talking about at least or less than. So I want to walk through an example of this and how Binomcdf comes into play here. In this case, talk about blue marbles, which the probability of that is 20%. So I'm going to do P equals 20%. Now they're asking here that I choose less than 5 blue marbles. So let's see. Less than 5. First of all, I want to figure out what is less than 5. I could get 0 blue marbles, 1, 2, 3, or 4. Those are the ones I'm dealing with. Those are the only combinations I care about. 5 through 15, don't need those. So here's what I can do. There are a couple of ways I can go about this problem. There's the long way, which was very similar to what I did below. I could do, all right, find the probability of getting 0 marbles. Use my formula here. Probability of success, 20%. 0 successes. Probability of failure, 80. 15. All right. Now I got to do it for 1. So I'm going to add, okay, 15, 1.21. I'm already running out of room here. As you can see, this takes a lot of effort. Oh, I didn't want to do that. Okay. And then in this case, I would have 14 failures. And then I got to go 15 over 2. I got to keep doing this all the way up to 4. That is a lot of work. If only there was an easier way to do this. But there is. That is what Binomcdf does. What Binomcdf does, it's a pretty cool function. What it does is you enter in number of trials, probability of, number of trials in this case is 15, probability of success, 0.2, and what Binomcdf says is, I'm going to calculate all the combinations you want to, starting from 0 all the way up to whatever number you give me up here. So in this case, I want 0, 1, 2, 3, 4. So I want 0 to 4. So I would enter in 15, 0.2, and 4. I'm going to do that right now. Now you want to get to that under the distribution button on your calculator, like you've used for normal distributions. So I'm going to enter these in, 15, 0.2, and then 4. And pretty high probability here. Using this, I end up getting 0.836, about that. I rounded. Now, I could have added up all those combinations, but what the calculator was able to do for me was it said, okay, I'm going to start at 0 combinations, and you tell me when to stop. And I said, okay, I want you to stop at 4. So half the battle here is you got to figure out what you need, what you don't need. It's not just as simple as just running to your calculator and just plugging in numbers. Figure out what you need and what you don't need. Like, let's take a look at this one. This one says, choose at least 8 marbles. So I want to think, all right, if I'm choosing at least 8, that means I could have 8, 9, 10, 11, 12, 13, 14, 15. Wow, that is a lot of combinations. So those are the ones I need. The ones I don't need would be 0 through 7 here. So these are the ones I need. Now I can do this whole combination thing. I can add up all the combinations of 8, 9, 10, 11, 12, 13, 14. That's a lot of work. Or I can use Binomcdf, because right here, I notice what I don't need. I don't need 0 through 7. So what I'm going to do is I'm going to say, all right, calculator, give me all the combinations starting at 0. Up, I need the probability of red. Okay, 0.3. Give me all the combinations starting at 0 all the way up to 7. So that's what I'm going to do right now. I'm going to do that. And maybe you're going to do that along with me. It's helpful to do this. So Binomcdf, I'm going to enter in 15. I'm going to enter in 0.3. And then I'm going to enter in 7. And what the calculator just gave me, it gave me a nice little answer here. This gave me everything from all the combinations from 0 all the way up to 7. And I got 0.949. So this is what I don't need. I don't need about 95%, which means the only percentage left over here is going to be about 5%. So that would be my answer here. So the trick with Binomcdf is you're telling your calculator, start adding up all the different probability combinations, starting from 0 up until the last number you give me. And again, it seems to be the at least thing, or at most, or, you know, those keywords seem to be throwing people off. So that's why what I do when I read these problems, I figure out what do I need, what don't I need. Like, let's see, I'm going to try another one of these. Here's another one. Choose at least 8. Oh, that's the one I just did. Whoops, that's all right. Choose at least 1. All right, this is an awesome one. All right, so if I'm choosing at least 1, that means I could get 1, 2, 3, 4, 5, all the way up to 15. Man, all right, so that's everything I need. What don't I need? In this case, the only thing I don't need is 0. So instead of going 1 through 15, finding all those combinations, I can just figure out the probability of getting 0 blue marbles and then subtract that from 1. And, you know, I could use Binomcdf for that, even though there's only one real combination of getting 0. So, I mean, that would just mean, you know, for blue, what's the probability of blue? That is 0.2. So if I'm not getting any blue marbles, that would mean, well, I'll do the combination. What the heck? 15, 0. Probability of getting a blue marble, 0. And then probability of not getting a blue marble in this case would be 15. So I can use NCR. There are a lot of different ways I can get here now. Well, hopefully you're getting the idea here. So I'm going to go 15. I'm going to use NCR for this. That's always I like to get that practice because more often than not, this is going to be the formula you would see on the AP exam right here. They're not going to give you a calculator function and they expect you to answer it. What they want to know is that you understand probability. So chances are you're going to see it as a calculator function like this. I mean, as a formula, as opposed to that calculator function. All right, so then 0.8 to the 15th power, and then, ooh, okay. So for this, I would get 0.035. That's what I don't need. I need everything else. So I can do 1 minus 0.035, and doing some quick and dirty math, I get 96.5%. So again, the key here is figure out what you need, what you don't need. And remember, Binomcdf, I'm going to write that here. Binomcdf, this function, what it does is you give it the number of trials. You give it probability of success. And then, starting at 0, the highest number of combinations you need. Take the time to think about it. Don't just read the problem and try plugging in numbers. Take the time to think about it. That's the best advice I can give you. Like I did in these examples. I figured out, what do I need? What don't I need? That will help you solve these problems a lot easier. Best of luck.